Hey guys, this is part 2 of that video about this problem. So what happened was we've calculated the time all the way to landing here to be 3.96 seconds. And the way that we calculated that was using two problems. So we considered this projectile from one platform to the next as a two-problem thing. So we had the time it reached to the apex and the time it took for it to fall, and that's how we ended up solving that time problem there. Because time is the important thing, because time dictates how long that projectile is going to be in the air and how far it's going to travel. So time is a very important variable that you need to calculate. So what I want to do in this video is do a different way to solve this problem, right? So I'm going to do it. I'm going to solve this problem as a quadratic equation because it's important that you understand how to attack this problem and see how this problem relates to the shape that projectile follows. It's because of the time factor that that projectile follows this weird parabolic parabola shape, right? Now, I talked about that we're not going to get the whole time, which involves the projectile going all the way up and back down. So when you solve this problem, you're going to get two solutions. You're going to get the solution for the time of the projectile being there and the time for the projectile to fall from that point down here, right? Okay, so let's write down our notes. Okay, 30 meters per second, angle is 60 degrees, height is 26 meters. And guys, just remember, we're analyzing the problems from the ground to the higher platform. The same principle applies from the higher platform back to the ground. So what instead you're going to do, if you're doing it that way, you're going to be calculating the apex height from the platform, and then you're going to be calculating the drop height from the top, the apex of that projectile launched from the platform to its fall. And that's how you're going to get the time value. It's the same problem, just done backwards. All right. We know gravity is equal to 9.8. We calculated our horizontal component to be 15, which was the cosine component. Vertical component ended up being 26 meters per second. And we found it out using our sine component. Okay. So it looks like this. When we do a little bit of playing around with this expression, it comes to resemble a quadratic equation. So I'm going to put this term at the front, this in the middle, and that's going to be on the other side. And I'm going to equal this expression to 0. So that becomes squared minus, plus ut minus sy is equal to 0. Notice here that I've treated my vertical displacement as positive because I'm landing a positive height. If I was being launched from the platform down, I'm going to fall a distance of a distance of 26 meters. So that means that'll be a negative there. That means when I bring it to the other side, that'll be a positive. So that's a key thing as well that you need to remember. Okay. So now we can start putting in our values. Half times 9.8 t squared. That's one term. Plus, we got u, which was 26 meters per second, or uy. So it's 26. And that's our next t coefficient. And then we have sy, which happens to be 26 meters as well. And that's all going to be equal to 0. So we've derived this expression, which is the quadratic solution. And it's going to look like this for us. It's going to look like negative vertical component, the velocity, plus the square of that vertical component minus 2 times 9.2 times gravity times vertical displacement over gravity. That's a negative gravity. Okay, so all we have to do is sub in our values in here and break that that down until we get to a solution. Okay, so we know our initial velocity is 26, negative 26, plus or minus the square of 26 minus 2 times 9.8, gravity, times SY, which is 26. And we divide that by negative 9.8. Minus 26 plus or minus the square root of 676, which is the square of 26, and that's going to come down to a value of 509.6. 26 times 9.8 times 2, and that's all got to be divided by negative 9.8. Keep on going down. Okay. The square root of this difference is going to give you 12.9 plus or minus 26 divided by 9.8 is going to give you two results. You're going to have in the negative value, you're going to have where you use this one, you're going to get 3.96. And when you use the plus, you're going to get 1.34. Now, if you have a look at these answers, you can see that we've already calculated 3.96. This other answer here, 1.34, it's the time for that to fall there. Now, again, once you have these seconds, you have these values, you can calculate the range. You can also do other calculations with that time value.